Hi, my name is Brian Ulicny. I'm the Vice President of Thomson Reuters Labs in the Americas. And I'm going to talk today about some really interesting work that we're doing in the labs around deep learning for legal natural language processing. So first, a little bit of background. So Thomson Reuters is a very large information provider. We provide information to professionals of various kinds, particularly legal professionals through our Westlaw platform, tax professionals, global trade professionals, and of course, we also have the Reuters News Agency, which is one of the most trusted news agencies in the world. We've had reporters in over 100 countries for over 100 years, and we're one of the world's most trusted providers of news and information. And in general, our business is to provide professionals of various kinds with the information that they need to make the important decisions that they make and to do their jobs effectively. So I had one of 5 labs globally for Thomson Reuters. We're based in Boston. We also have labs in the Toronto, Waterloo area in Ontario, where Thomson Reuters is based, in London and in Zurich, Switzerland. And then we also have a startup fund, an investment fund based in New York City. So our job is to partner with internal and external customers, startups and academics, and to innovate around new ways that we can leverage all of the incredible, rich, curated data that Thomson Reuters has and continues to provide to our customers, find new ways to leverage that to help solve customer problems. And Thomson Reuters puts out gigabytes of data every day to our customers. So it's big data is part of our bread and butter as a company. Today I'm going to be talking about a use case that we've been working on for a while now around a service that we call Courtwire. So Courtwire is part of our Westlaw offering, and it is a service that takes complaints, civil complaints. So when someone is suing someone else in civil court, they file their law firm, the law firm of their attorney files a civil complaint and saying, party A is suing party B for the following reasons and is seeking the following damages. And so we either electronically retrieve these civil complaints when they're filed from websites, or in some cases we actually have runners within the physical courthouse who take the complaint as it's filed, scan it, and send it to be summarized. So it's important that these summaries are done quickly. The audience for this service is both law firms who would like to know that a court case has been filed of a particular kind so that they can offer their services to the defendants in the case, because they say have expertise in a particular kind of case that this represents. The other audience for this service is investors. So investors want to know, I'm heavily invested in company B, and I see that they're being sued. That may or may not, I may or may not want to change my investment position based on that news. So it's important that the cases be summarized quickly and get out to our customers as quickly as possible. But of course, the summaries also have to be accurate and usable. So what we've initially set out to do within the lab is to see whether we could use some of these new deep learning techniques to produce accurate summaries of both what the case is about, as far as why is party A suing party B, and secondly, can we extract accurately or summarize accurately the damages that are being sought, because obviously, you know, lawyers are more interested in a case that has high that are high cost, high payoff than low, you know, small claims events, for example. So here's what a civil complaint looks like. These are typically 10 to 100 pages of PDF documents. They are generally in plain text, but they're not structured in any you know, canonical way. So a lawyer can write their civil complaint in basically any format that they like. I mean, of course, there are commonalities, but there is no standard structure to a civil complaint. And again, they're 10 to 100 pages typically of text. And what we want to do here is, here's an example of the sort of human-generated summaries that we want to produce, that we want the machine to produce. So we have this case, C&J Clark Americas Inc. Versus Jose Baez versus C&J Clark America Inc. And we want to generate a summary like the following. So defendant discriminated against plaintiff on account of his disability by denying access to full and equal enjoyment of the goods and services of the facility. And then the damages that are being sought are $1,000 in compensatory damages plus punitive damages, declaratory and injunctive relief, expenses, fees, and costs. So it's not enough, I just want to point out here that it's not enough to sort of identify the $1,000 there. It's really important to our audience that what that $1,000 covers. It's this list of things: compensatory damages, punitive damage, etc. So you can't just do simple pattern matching here. So just jumping ahead to the chase, what we did here was we trained a neural network model that would produce the summaries that we wanted using a deep neural net. And the way this neural network works is that by training this model on years of pairs of summaries and the underlying text that we had produced over the years, we were able to create a model that produced the summaries word by word by saying, given the text that's in front of me and given the summaries that I've seen previously, I predict that the first word of the summary should be this, and then the second word should be that, and then the word given the underlying text and the previous words that I've generated, the third word should be this, and so on until it generates an end of summary symbol. So what this means essentially is that we've created a sort of language model for summaries based on training on all of these previous examples that we've seen. And the summaries that we produce are highly abstractive. So since what we're not doing is what's traditionally done in natural language, or had been traditionally done in summarization techniques, where those computerized or automated techniques used extractive summaries. So what they would do would identify a piece of the text that could serve as a summary of the entire text. So typically by looking at, say, the distribution of keywords in a document, it would find sort of the sentences that had the highest concentration of those keywords, and then it would say, well, that sentence must be representative of the whole document, or the terms with the highest TF-IDF score. Those must be a summary of the entire document because they contain the highest density of the most specific terms within the text. That's not what we're doing. What the neural network model that we train does is it learns to generate summaries on the basis of the summaries that it's already seen. So it learns to speak in the same style and produce a similar summary to what it's seen before based on the underlying text and the text of the summary that it's already generated. So here's some of the results that we get from this model. So what we do when we generate this model is we have staff attorneys who evaluate the performance of the system in a variety of dimensions. So those dimensions include the factual accuracy of the summary, the grammaticality of it, the sort of conformance to the style of summaries that have been generated before, and so on. And we always have multiple editors evaluate these summaries. And very importantly, one of the crucial things I think that I'd like to emphasize here is we always do this in a double-blind way. So we don't want evaluators to say, oh, to judge, the computer-generated summaries more harshly or less harshly than human-generated summaries. So we provide to the evaluators both machine-generated summaries and human-generated summaries, and we don't tell them which is which, and we ask them to evaluate them in the same dimensions. So here are some of the results that we've seen, which are really, impressive based on, previous work that has been done on automatic summarization. So what we see here is that the machine in the orange bar more often produces a summary that's judged excellent across the board than the human. But then overall, the computer is slightly worse, but within a statistical striking distance of the human generated summaries in terms of overall quality. So this means that by providing these computer generated summaries to our editors as a first draft when they initially begin the summarization process, they have a huge leg up in terms of efficiency in being able to say, yep, this computer generated summary looks correct. I might have to tweak one or two minor things, but otherwise being able to have this first draft generated by the machines is a huge advantage to the humans who are doing this summarization task. So when we began this project, we began by looking at traditional automated summarization techniques, and we found that they were just not at all suitable to producing the kind of summaries that we needed for the quality that we needed for this task. And so by turning to these deep learning models that use these language model-like techniques to produce abstractive summarization, we were able to make considerable progress. So here's a little quiz for, I know this is not directly interactive right now, but I'll let you vote in the privacy of your own viewing. So what I'm going to present is two summaries, one generated by humans and one generated by machines, and I'll let you guess which is which. So the first summary says, and I'm not going to show you the civil complaint, of course, which would take too long to read. But the first summary says defendants affected unauthorized interception and receipt of satellite programming by ordering programming for residential use and subsequently displaying the programming in a commercial establishment for commercial gain without authorization. And then the second example is, the second summary is defendants unlawfully intercepted, received, published, divulged, displayed, and exhibited plaintiff's satellite programming transmission signals without getting authorization from plaintiff for commercial advantage. All right, so which do we think is the machine? Which do we think is the human? So here's the answer. So the A column is the machine generated summary and the B column is the human generated summary. So, I think whenever I've presented this, it's, 50-50 usually about who people think produced which summary. So let's see if we do any better in the second go around here. Defendant failed to properly evaluate and treat plaintiff's injuries. That's very straightforward and to the point. Defendant committed medical malpractice by failing to give standard medical treatment to plaintiff causing injuries. So here it was the human that was very succinct, and the machine is slightly more verbose, but it is very difficult to say which one, obviously both of them seem to capture the sort of same essence of the case here. And then finally, a defendant violated the procedural requirements of the plaintiffs in its implementing regulations by failure to initiate and complete consultation with the plaintiffs so as to protect the species and natural habitat. Plaintiff seeks declaration that defendant has violated substantive requirements of the ESA, the Endangered Species Act, by failing to ensure that implementation of the NFIP in Monterey County is not likely to jeopardize the continued existence of listed species or result in the destruction or adverse modification of the critical habitat of such species. Okay, so obviously the second one is much more detailed, and it's in fact the machine-generated summary. So I think you'll agree that these are pretty impressive. One thing to note here is that the machine-generated model learns to incorporate, for example, in this third summary, it learns to incorporate vocabulary that it has never seen before in the training corpus, and knows when to insert those terms from the case into the summary, which is very impressive and necessary, really, in order to accommodate the sort of changing nature of things that people could be sued over in court. Okay, so finally, I just want to talk briefly about some additional avenues that this project took on. So in addition to generating these summaries of what the case is about and what the damages that were being sought, the editors of this service also had to generate, also have to produce certain metadata about the case as part of the offering. So they identify, is this a federal case versus a state case? What state? What's the court name? When was this filed? The filing date is actually interesting because the filing date is often not part of the text itself, but it appears in say, a rubber stamp on the paper copy. There's a topic code. These are called nature of suit codes, NOS codes. The case type, the plaintiffs and the attorneys, and so on. So all of these things we need to extract from these documents and provide to the customers. And what we found was that you would think, well, a lot of these metadata fields should be straightforward, pattern matching instances, that you should be able to just write a regular expression that captures these fields and identifies them. But what we found was that while, in principle, you can write a regular expression that will match any, set of instances, because if the regular expression is arbitrarily complex, but a decently understandable regular expression, we found that there was a ceiling at which its performance was not quite up to the standard that we needed it to be. And so simple pattern matching really was not adequate here for extracting all of these metadata fields. So again, we treated these as a deep learning use case, where we trained models to identify these pieces of information essentially as a sort of summary itself. So the system learned to output court type and plaintiff attorneys and so on as a kind of summarization or sequence to sequence task, rather than a information extraction pattern matching task. And we saw that, and we see here that the result of treating things this way actually pays off quite highly. So things like the court type and so on are very, very accurately extracted. Things like federal statutes are still somewhat difficult for the machine to recognize completely accurately, but this still gives our human editors a definite heads up or leg up in terms of being able to extract this information efficiently and get it to our customers in a timely manner. All right, so I just want to emphasize here that a few things. So one, Thomson Reuters plays an important part in the legal ecosystem. So we provide, a huge amount of annotated legal data to the U.S. legal field and lawyers around the world. In some instances, Thomson Reuters actually, our editors will notice, for example, that when a legal opinion comes out that the judge has made an error when he or she wrote it down, and that they will contact the judge and say, I think that you meant to say, the defendant is not such and such rather than the defendant is such and such. And we will provide those kinds of feedback to the American legal system, which are integrated then eventually into the canonical representation of these cases. So Thomson Reuters plays an important part in this legal system. We hire a huge number of legal editorial staff to do these tasks. And what we're seeing here is that by having human in the loop, AI-assisted editorial processes, we can make our lawyer editors much more efficient, have a higher quality output, and be able to cover more of the legal data that is important to our American and the legal system worldwide. Secondly, so we've seen that abstractive summarization and so on can be very, very effective and accurate and produce better results sometimes and more grammatical results consistently than human-generated summarization data. But it requires a lot of training data. So we trained the system on a dozen years or so of past training data, and that amount of training data is often very, very hard to find. So we're lucky within Thomson Reuters that we have this huge amount of training data that we can leverage these deep learning models on. And finally, I think that, we're just seeing an incredible increase in momentum in how well these deep learning models can perform tasks that we used to think, required specialized training. We used to think that, only trained people with legal training could do some of these tasks, like the summarization tasks that I described. But we're seeing that because or where there's a sufficient amount of training data like this, we can achieve human levels of accuracy in these kinds of tasks. And by using those technologies to provide first drafts to our editors, we can make them much more effective and efficient. And so thanks for your attention, and I look forward to answering any questions.